Yeah, he's calling. You see it?
Yeah.
Yeah.
I'd love to get a shot of underneath them.
Do the eggs hatch early without parental care?
Yes, they do. And you know, because these bad things are happening, then yeah, basically they will hatch early. And so it's like plan A, you know, if you want to think of like embryos, plan A, dad will take care of it. Plan B, dad is gone, I'm on my own, now I may need to hatch early to defend myself.
Is there any physiological or behavioral response to the father leaving the clutch?
We don't know. We don't know, like we don't know how the embryos know that dad is around. I mean, is it just because like they're wet enough, or do they actually, you know, feel the like particular vibrations of what it feels like when dad is cuddling a clutch? We don't know that. These are like interesting questions that certainly could be investigated. There are different hatching times, right? But I think, you know, how we're thinking about it now and like what the evidence supports is that they're not necessarily directly responding to the absence of the father, but they're responding to bad things that happen in the absence of their father, right? So like it might be dad is gone, but it's raining and raining and raining, and therefore I'm not drying out and it's actually okay. But it might be dad is gone and there's no water delivery service and it's not raining, so now we're drying out, and so then you have to hatch early.
This is the female. Can you see the eggs in the size?
Wow.
And this is the guy that was probably calling to her, and probably we screwed up.
We screwed up as in we gave him away.
Okay, well, they normally stop there and they don't move. If we don't touch them, we try to still.
It almost looks like she flattened her body even
Yeah.
more.
And go. Yeah. You're fine. You're fine.
With the feet and the female, wow.
So if the parent's separated from its clutch, you run the risk of drying out.
And you're also accumulating ammonia without having access to water to kind of wash it away.
One of the things, waste disposal is another issue, right, that life faces. For tadpoles and, you know, for frog eggs in the water, the cheap way to do waste disposal is ammonia. And so this is like nitrogenous waste that comes from metabolism of proteins. Because ammonia, like, it just diffuses away in the water, and that's like cheap and easy. For animals that are terrestrial, live on land, they don't have enough water to use that.
Parental care, or male care in this case, may affect the weight of nitrogen excretion. So actually now we know that when the parents are taking care of the clutch, when the male is like putting water on the clutch and taking care, embryo seems to excrete mainly ammonia. But when we remove the parents, or for any reason there is probably less care for one specific clutch, the embryos may start like producing urea, and that's a way to avoid like ammonia toxicity. Okay. Yeah.
So, like an adult frog that is terrestrial doesn't use ammonia as its waste product because that would be toxic, and it doesn't have enough water to get rid of it. So they make urea. So we used to think, the general kind of received knowledge is that, so frogs have these enzymes that they can use to get rid of ammonia and make urea instead. Typically we think those come online at metamorphosis, right, when they go up onto land. Javier is asking whether these terrestrial eggs, and particularly terrestrial eggs that are in situations of drying out, could also have the ability to make urea instead of ammonia.
When I started talking with Karen was something about like, hey, I would like to study how these adaptations, like parental adaptations, may have helped like colonization, right, of land in reproduction.
And yeah, so he has evidence both for the terrestrial foam nesting species that he studies, and also for some glass frogs, that these very early life stages in a terrestrial environment faced with this risk of drying out are using urea.
So we saw like this question of how excretion may be something important in them, because this was like an unknown question, like an unknown subject in biology. We knew something about how rate of excretions are like between adults, aquatic and terrestrial adults, and we know that terrestrial adults excrete urea, while aquatic adults excrete ammonia, which is like related with environment. So in this context of what happens when you have like aquatic eggs or aquatic embryos and when you have aquatic or terrestrial embryos, it's the same. Like there are like some similarities in the nitrogen excretion ability, and if they are different, because they live in these like really changing environments, can the embryos like change a little bit this kind of like physiological pattern, or it's fixed? It seems like it isn't fixed. It's something that they can change.